The first thing Dr. Ethan Mercer noticed wasn't the speed. It wasn't the brightness spike or the thermal irregularity or the faint asymmetric tail. It was the silence. The kind of silence that settles inside a lab when every model, every assumption, every line of code fails at the exact same damn time. I remember standing beside him, still holding the printout in my hand, the one with the timestamp labeled 061241 UTC, a moment I would later learn to fear almost superstitiously, when Ethan whispered something I had never heard from him before. "Tell me this is an instrument error." And then, after a breath that didn't quite finish, "Please." If you listen to this story to the end, and I hope you do, there's one thing you'll never forget again. Sometimes cosmic danger doesn't arrive with fire or light. Sometimes it arrives quietly, like a number that shouldn't change, but does. That was the morning everything started to unravel. The morning we realized the interstellar object classified as 3I AT Atlas might no longer be following the trajectory every agency had sworn was nominal, safe, stable, predictable. The morning we stopped trusting the orbit, and the morning a handful of scientists inside a Pasadena monitoring lab felt something we were trained never to feel: fear. When the story begins, at least for you, the listener, 3I AT Atlas is still millions of miles from Earth, far enough that you could convince yourself nothing bad could possibly happen. But distance doesn't matter. Not with interstellar objects. Not with something that wasn't born in our solar system. Not with something that had already defied photometric expectations, mass estimations, albedo predictions, and thermal norms. We had excuses for all of that, of course. Scientists are good at excuses, better at them than we like to admit. Atypical dust composition, low rotational phase sampling, anisotropic venting, model compression artifacts, under-resolved tail geometry. But that morning, excuses weren't going to help. Not when the trajectory shifted. Not when it shifted toward us. I should tell you where we were. The lab was the Orbital Prediction Cluster at NASA's Jet Propulsion Laboratory, West Wing, second floor, a small, over-air-conditioned room filled with humming servers, a half-dozen workstations, and 3 exhausted astrophysicists fueled by vending machine coffee and residual arrogance. My badge still said Aurora Zhao, visiting research analyst. MIT had sent me to observe, maybe learn something. What I learned instead was how fragile a solar system can feel. We were on rotational night shift, the 2 a.m. to 10 a.m. window. Half the building was dark. Pasadena outside our windows glowed faintly under a marine layer that almost touched the San Gabriel Mountains. The coffee machine had jammed 2 hours earlier. Everything felt slow and heavy. Until it wasn't. The anomaly came through the Arizona feed first. A faint correction in radial velocity. Small, harmless looking. But the radial velocity of an interstellar object is not supposed to do whatever that was. A jump. No, a nudge. A nudge in the wrong direction. The wrong direction meaning toward the vector that eventually intersects Earth's orbital path. I don't remember who noticed it first. Maybe it was me. Maybe it was Ethan. Maybe it was the software quietly screaming in red text across the displays. We cross-checked with Mauna Kea, then with Lowell Observatory, then with Catalina. Same result. The nudge wasn't noise. The nudge was real. "Run it again," Ethan said. We did. The display blinked, recalculated, then painted the same thin crimson arc across the projection sphere, the kind of arc no one in this building ever wanted to see, connected to an object traveling tens of kilometers per second. A possible Earth-intersect trajectory requires three things: a shift in vector, a failure of compensatory factors, and a continuation of trend. We had the first. We feared the second. We prayed against the third. But prayers don't mean anything to interstellar objects. The numbers kept shifting. "Okay," Ethan said finally, voice thin. "Let's just see it." The room fell silent. I keyed in the parameters. The system began rendering. A soft hum filled the background. 12 seconds. Then the map resolved. The solar system unfolded in pale blue light. The arcs began tracing: Mercury, Venus, Earth, Mars. Then the incoming vector. Then the potential corridor of positional uncertainty. I felt my stomach tighten as the corridor thickened, elongated, bent. Bent toward us. Not a collision course. Not yet. But no longer comfortably away from one either. Ethan exhaled sharply. Oh, God. But the worst part wasn't the projection itself. The worst part was the fact that it wasn't supposed to move at all. This object had no business changing vector, not by that magnitude, not at that distance, not with that erratic drift signature. It shouldn't have been possible. Each of us knew what that meant. If the models fail at distance, they fail harder closer in. We had entered the realm of unpredictability, and unpredictability is the enemy of orbital certainty. By 7 a.m., the room felt like an ICU ward. Nobody spoke above a whisper. Nobody blinked for too long. Nobody wanted to be the one to vocalize the thought hanging over us. What if 3I AT Atlas is drifting into a high-risk corridor? Not a collision corridor, just high risk. That was scary enough. Because when you're dealing with an interstellar object, high risk is a euphemism, a polite way of saying, we don't know, and the things we don't know are the ones that ruin planets. I remember checking the Arecibo archival data for the fourth time, hoping to find an inconsistency we could blame on old calibration. But everything lined up. Everything pointed the same direction. The shift was real. The shift was continuing. And worse, the shift was accelerating. Not by much. Not enough for the public. Not enough to trigger automated alerts. But enough for us. Enough for a handful of tired scientists in a cold lab to realize that something they'd been told was safe might no longer be safe at all. Ethan finally broke the silence. We need to file the preliminary deviation report. No, said Marissa Hale, the mission analyst who had joined us 30 minutes earlier. Not yet. It's protocol. It's panic, she said. It's data, I said quietly, and it's not stabilizing. Marissa turned toward me, eyes sharp. She was older than the rest of us, steadier, the kind of person who'd seen budget cuts, political battles, failed missions, and bureaucratic stupidity up close. But this wasn't a political problem. This wasn't a mission failure. This was physics behaving incorrectly. Her voice lowered. You know what happens if we submit a deviation report on an interstellar object trending toward Earth? We follow procedure, Ethan said. She shook her head. No. Washington starts calling. Committees get briefed. You know how many congressional staffers understand orbital drift variance? 0. You know how many will assume this means incoming impact? All of them. She rubbed her forehead. We need more data. But data wasn't going to save us, because the more data we pulled, the more the curve bent. And the more the curve bent, the closer it came to that invisible line between safe and not safe. There's something you should understand about risk corridors. They don't require certainty. They don't even require probability. They require possibility. And for the first time since 3I AT Atlas had entered observational range, Earth had entered the possibility envelope. Nobody said it, but we all knew. You can't unsee that. At 8:03 a.m., the system chimed, a soft, sharp, metallic tone that sliced through the tension like a scalpel. Another update, another recalculation, another shift. A bigger one.
Not huge. Not dramatic. Not the kind that triggers system-wide alarms, but enough that when the new path rendered on the display, a thin white line crossed the Earth's orbital plane in a way that made my throat go dry. Not a hit. Not even close. But the direction was wrong. Wrong in the way a small crack inside a dam is wrong. Insignificant at first. Deadly if ignored. Ethan stepped back from the screen. "Oh God," he whispered. Marissa folded her arms, her composure cracking around the edges. And me? I just stared at the arc, unable to move, because the arc was beginning to curve like a question mark.
A question pointed straight at us. "One more update," Ethan said. "Just one more." We waited. Seconds stretched. The servers hummed. The sunlight outside climbed the mountains. Cars began filling the streets below. Life continued, as if nothing was happening. As if the universe didn't just bend a fraction of a degree toward our planet. The trajectory line repainted. A ripple passed across the rendering sphere. Then, a small, subtle movement toward Earth. Again. That was the moment fear arrived. Not panic, not dread. Fear. Clean, cold, precise. The kind of fear that wraps around the spine of a scientist when an equation stops behaving like an equation. When the universe does something it shouldn't. When nature breaks its own rules. "We need to tell them," I said softly. Ethan closed his eyes. Marissa swallowed hard. Nobody argued. Because the truth was unavoidable now. 3I AT Atlas was drifting. And for the first time, it was drifting in our direction. Ethan didn't move for several seconds after we saw the last projection. It felt as if the world around us paused. Even the low mechanical hum of the server racks seemed to dim for a moment, like the machines themselves were waiting to see how we would react. I stepped closer to the main console, not because I planned to touch anything, but because something inside me didn't want to stand still. Fear does that. It pushes your body into small, meaningless motions just so it doesn't collapse under the weight of uncertainty. "How stable is the drift?" I finally asked. Though what I meant was, how doomed are we? But scientists don't talk like that. Not even when the numbers suggest we probably should. Ethan zoomed into the vector line, isolating the most recent 40-minute window of motion. The drift wasn't just a wiggle or a calibration hiccup. It had a trend, a personality to it, a persistence that made my skin tighten. Objects don't move like that unless something internal is changing. As he scrolled through the telemetry, tiny fluctuations in brightness appeared, then vanished. Nothing that would catch public attention, but enough for trained eyes to recognize them as potential micro-outgassing cycles. Marissa leaned in, her voice calm but lacking its usual weight. That's cyclical behavior, too regular to be random, too quiet to be normal, Ethan added. If this thing is venting, it's doing it without the typical thermal spikes. I swallowed. Like a controlled bleed? He looked at me. Really looked. If it were a comet, I'd say no. But if it's interstellar, we don't have the right vocabulary. He wasn't trying to be dramatic, he was trying to be honest. And honesty in our line of work is sometimes more frightening than fiction. I opened the raw feed logs, scanning for anything we missed. Radiation spikes, telemetry drops, interference patterns, distortions in the coma silhouette. And that's when I saw it. A faint, almost invisible asymmetry forming along the nucleus path. Not enough to classify as fragmentation, not enough to raise an automated alert, but enough to suggest internal stress. Look here, I said, enlarging the frame. This contour wasn't present 2 hours ago. Marissa's eyes narrowed. Thermal deformation? Maybe, Ethan said, but his expression said otherwise. Or structural instability, I whispered. If a panel or crust breaks off, he finished my sentence for me. The trajectory shifts. We all knew what that meant. Fragmentation events, even microscopic ones, could alter an object's path by thousands of miles over long distances. And if it fragmented unevenly, even worse. It could introduce rotational chaos into the nucleus, making future projections unreliable. If that happened, the drift toward Earth wouldn't just continue, it could intensify. All it would take was the wrong crack at the wrong time. I felt a cold pressure building at the base of my spine. We need external verification, I said. Radar, if possible. Infrared, if not. Goldstone can't get a clear return at this distance, Marissa warned. The deviation report hadn't barely left our server queue when everything in the lab began to feel wrong in ways that had nothing to do with fear and everything to do with the growing sense that the universe was about to reveal something we weren't prepared to see. It wasn't dramatic at first. No alarms. No sudden catastrophic shift. Just this slow, creeping distortion in the data, like gravity itself was whispering in the margins. The lights in the room felt too bright. The air felt too dry. Every machine seemed to hum at a slightly different pitch than it had an hour ago. That's what tension does inside a lab. It makes familiar sounds feel hostile. 3 minutes after sending the deviation report, Washington hadn't responded yet, but other departments inside JPL had. The notification feed began flashing on Ethan's monitor. Trajectory review request, instrument verification ping, peer confirmation protocol, emergency photometric cross-check. The bureaucracy had awakened. Not fully, not loudly, but enough for us to feel the weight of its attention. We weren't alone with the data anymore, and that, strangely, made me more anxious, not less, because now it wasn't just us watching Atlas drift. It was everyone who understood what a drift meant. But the real problem, the real terror, started 40 minutes later, when a new cluster of data arrived, this time from Palomar. A follow-up photometric sweep. These sweeps were routine, scheduled, predictable. Yet nothing about the numbers on the screen was routine. Ethan opened the file. His eyes widened in a way I had never seen. not even during failed simulations. He said, "Aurora, tell me what you see here." I leaned over his shoulder, expecting maybe a refined brightness schema, maybe confirmation of the earlier asymmetry. Instead, I saw oscillations. Not random noise, not turbulence from atmospheric interference. Oscillations. Regular, rhythmic, pulsing gently along the outer edge of the coma like a heartbeat. Not a biological heartbeat, obviously, but a thermal modulation cycle. Controlled, periodic, as if the object was releasing small amounts of heat in intervals. No interstellar object is supposed to do that. I felt the blood drain from my face. "Please tell me you're seeing an artifact." Ethan didn't answer. He expanded the thermal bands, layering ultraviolet over infrared, then compositing with Polymar's high-resolution radial gradient mapping. The pulsing remained. Too clean to be a glitch, too stable to be atmospheric, too synchronized to be a coincidence. If it had been a comet, we would have expected jets, flare-ups, chaotic bursts, behaviors tied to sunlight exposure and thermal expansion, but this pulse was independent of the object's rotation, independent of solar illumination, independent of everything except itself. Then Marissa whispered, "It's compensating." Ethan turned toward her. "Compensating for what?" "Internal stress," she said, "or rotational shift, or heating. Something inside is trying to stabilize." "Comets don't stabilize," I said. "Interstellar debris doesn't stabilize." She corrected, "Nothing stabilizes unless something inside is failing." Her words hung in the air like toxic smoke.
For a moment, nobody moved. Nobody even blinked. Because what she said was more terrifying than any collision scenario. If the object was attempting, through natural or chaotic internal mechanisms, to maintain rotational equilibrium, it meant one thing: instability inside the nucleus. And instability meant drift, and drift meant unpredictability, and unpredictability meant danger. Ethan opened a new model. "Let's check rotational variance again." He fed in the new photometric oscillations. The system recalculated. A wireframe of the object's spin state emerged, erratic, yes, but with a strange pattern, a slight wobble repeating every 87 minutes. A non-gravitational rotational anomaly. "What the hell?" Ethan breathed. But before we could process it, the system pinged with another incoming dataset, this time from the deep synoptic array, radio reflections. Weak, sparse, but enough to provide a silhouette. The shape that emerged was wrong. A long, slightly curved central structure with irregular density zones, almost like internal cavities. Not hollow, not artificial, but brittle, fragile. A body under tension, something that could crack if stressed further. And cracks meant force releases, and force releases meant acceleration, and acceleration meant the drift toward Earth was likely not going to stop. My throat tightened as realization sank deeper. "This thing is not stable," I whispered. "It's not decaying," Ethan said. "It's stressed." "Stressed objects release energy," Marissa added. "And when interstellar objects release energy—" She didn't finish the sentence. She didn't have to. The object's drift wasn't the anomaly. The drift was a symptom. The anomaly was happening inside. The room's tension grew thicker, almost suffocating.
The servers hummed like distant thunder. Somewhere down the hall, a phone rang briefly, sharply, before being answered by someone who had no idea the data in our little lab was quietly rewriting the probability architecture of the next decade. My heartbeat felt synchronized with the thermal pulses on the screen. My breathing synced with the rhythm of the rotational wobble. It felt like the object wasn't just drifting toward Earth, it was drifting into me, into us, into the collective nervous system of every scientist watching it. At 9:06 a.m., we got the first response from Washington, a short encrypted request: provide detailed explanation of variance source. This was expected. What wasn't expected was the second part: include probability of impact corridor development if current drift continues. Marissa exhaled sharply. They're scared. No, Ethan corrected. They're preparing. Preparing for what? I asked. For a scenario we can't rule out anymore. We didn't answer immediately. We didn't know how. The drift was too new, the anomalies too fresh. But Washington doesn't wait for perfect data. It demands action, decisions, predictions. So we worked. The three of us, elbows pressed to the desk, eyes red, necks stiff, flipping between simulations like gamblers desperately trying to beat impossible odds. For the next hour, the lab was a pressure chamber. Every few minutes, we got another sliver of data from another observatory: Chile, Hawaii, Arizona, New Mexico. Each dataset made the shape of the truth blurrier, not clearer. The coma grew denser, the pulses became stronger, the rotational wobble sharpened, and the drift vector crept farther inward. At 10:18 a.m., another anomaly appeared, this time from a narrowband spectrographic sweep. A tiny spike in carbon monoxide emissions. Not a burst, not a flare, a leak. Slow, persistent, like a hairline fracture venting gas. That's bad, Ethan muttered. That's very bad, Marissa agreed. Why? I asked, though I already suspected the answer. Because if the crack grows, she said, the vent will intensify. And if the vent intensifies, acceleration, Ethan finished. And if acceleration increases, the drift becomes a shove. Suddenly, it felt too warm in the lab, the machines too loud, the screens too bright. I wanted to step back, to breathe, to blink, but something inside me wouldn't let me move, as if any shift in posture might somehow influence the trajectory of the object millions of miles away. At 11:02 a.m., we got our pivot moment, the kind of moment that slices a story in half. A new dataset from the Lowell Observatory arrived, time-stamped 40 minutes earlier. A very faint, nearly invisible microfragment had broken free from the object. It was small, yes, only a few meters across, invisible to public telescopes, harmlessly drifting. But its motion relative to the main body told the real story: internal failure, structural instability. A piece of Atlas had crumbled away like a dust flake shaking off an old, weakened sculpture. That's when Ethan said the words we were all thinking. It's not drifting toward Earth, it's falling apart. Is that better or worse? I asked quietly. He didn't answer, because there was no answer. A stable object was predictable. A drifting object was dangerous, but a fragmenting object, that was chaos incarnate. The moment microfragmentation begins, small forces become large ones. Jets gain strength, rotation destabilizes, internal stress redistributes, and the trajectory, already fragile, can swing dramatically with each new crack. Atlas wasn't moving toward Earth intentionally, it wasn't behaving with purpose. It was simply dying. And a dying interstellar object is one of the most unpredictable things in the universe. We needed perspective, clarity, someone outside the panic vortex, so Ethan made the call to one of the senior orbital analysts in Washington, Dr. Caroline Moss. She picked up on the second ring. Her voice was calm, almost too calm. We saw the deviation report. Explain. Ethan tried, he really did, but halfway through, he stumbled. He never stumbled. So I stepped in, summarizing everything: the pulses, the wobble, the microfragment, the CO leak. There was silence on the other end. Then she said, "If the drift continues at the current rate, what's the probability corridor?" "Low, but rising," Ethan said. "How low?" "Below 1%, but rising toward 2. And if the internal stress worsens—" Ethan hesitated. 10, he whispered. "Maybe more, depending on the next crack." A long silence. Then her tone hardened. "Keep watching it. Keep updating us, and do not, under any circumstances, let this leak beyond controlled channels." Controlled channels, meaning, if it gets out now, people panic. When the call ended, we looked at one another, and the truth settled like ash. The government was worried. Not enough to announce anything, but enough to tighten the circle, enough to start preparing for the impossible, enough to treat this drift not as a curiosity, but as a threat. The rest of the day blurred, more data, more recalculations, more theories, more inconsistencies. By early afternoon, the sunlight streaming through the lab windows felt hostile, like an interruption from a world that didn't realize how fragile it had become. At 3 p.m., the final anomaly arrived. A small but significant acceleration spike from the CO venting. Not huge, not dramatic, but unmistakable. Atlas had sped up, not by much, but enough for the model to react violently, enough for the system to redraw the Earth corridor wider, enough for the tiny line of possibility to thicken into something that resembled a warning. And when Ethan whispered, "It's worse than we thought," I realized something I hadn't understood until that moment. We weren't watching an interstellar object drift. We were watching a dying giant fall through our solar system. And the path of a dying giant is never predictable.
The day the truth revealed itself didn't start with screaming alarms or catastrophic data spikes. It began quietly, almost politely, with a scheduled calibration of the deep space infrared array. Calibration cycles were routine, boring even. They were the closest thing we ever got to normalcy during those weeks. But that morning, as the system synced with the array and pulled the latest thermal imprint of 3I over Atlas into our lab, I noticed something that made my stomach twist. The kind of twist that comes before your mind understands what your instincts already know. The temperature profile wasn't just wrong, it was reversed. Not flipped, not mirrored, reversed. The hottest region of the object was no longer at the area facing the sun. It had migrated, slowly, deliberately, like heat shifting along a fault line. Ethan leaned in beside me, brows tightening, the blue-white reflection of the thermal map lighting his face. "That shouldn't be possible," he said. "Not unless the internal structure is redistributing heat faster than the surface can radiate." "That or the fracture widened," added Marissa, stepping closer. "If internal cavities are exposed, heat could relocate along structural weaknesses." I shook my head. "But this cleanly. This looks directed." She stared at me. "You're not suggesting—" "I'm not suggesting anything. I'm saying the heat is moving the way fluids move when guided by internal pressure." Her expression shifted from confusion to something far sharper. Fear mixed with fascination. Scientist instincts colliding with human instincts. Because if I was right, then the internal cavity inside Atlas wasn't just expanding, it was reorganizing. Something deeper was happening. Something systemic. Before we could process it, a second data set dropped into the queue. This time from the Goldstone radar sweep. I expected noise. At this distance, the return should have been borderline useless. But the signal wasn't useless. It was strong. too strong, as if the object's surface had become more reflective. Ethan brought the radar silhouette onto the main screen. And that's when everything began to unravel. The silhouette wasn't the same shape we had seen yesterday. Yesterday it had been uneven, irregular, almost sculptural. Today it was leaner, tighter. A long axis rotation still present, but compressed somehow, as if the nucleus had lost mass or redistributed it into a more stable configuration. Objects don't do that. Not naturally, not in silence, not without releasing enough debris or heat to trigger obvious signatures. "This is a mistake," Ethan said, zooming in. "Goldstone must have—" But the sentence died, because even as he spoke, the shape sharpened, the contours solidifying with each pass, revealing details that stole the air from our lungs.
The cavity we'd suspected. It wasn't a cavity. It was a fault line, running nearly the entire length of the nucleus. "Holy," Ethan whispered, but he didn't finish. Nobody finished anything. We just stared as the fault line pulsed. Yes, pulsed, with faint infrared activity, synchronized perfectly with the thermal rhythm we had seen earlier. The pulses weren't random. They weren't chaotic. They were timed. Controlled. But controlled by what? Not intelligence, not intention, but by internal physics we didn't understand. A system reacting to stress, redistributing energy, preventing catastrophic fracture. Not purposeful, but undeniably organized. Then the radar signature changed. A flicker, a distortion, a bloom of reflective material scattering from the fault line like dust shaken off a collapsing cliff, except it wasn't dust. It had shape. A cluster of microfragments, thin, needle-like shards, ejecting at low velocity, spinning in chaotic but strangely planar patterns around the nucleus. Marissa inhaled sharply. "That's not debris. That's a stress cascade." Ethan stepped back. "If it's cascading, then fragmentation isn't just possible, it's imminent." And that was when the real horror slid into my mind like a cold blade. An interstellar object doesn't break apart cleanly. It breaks apart dynamically, each fracture altering rotation, each rotation shift altering trajectory, each trajectory shift altering stress, each new stress creating more fractures. A runaway loop. A death spiral. "Stop it," Marissa snapped suddenly. "Stop the sim. You're spiraling us into assumptions." "I'm not spiraling. The object is." Silence swallowed the room. Not fear, not shock. Something heavier. A shared recognition that we were no longer dealing with anomalies. We were dealing with a process. A process unfolding inside an object large enough and unstable enough to reshape its trajectory in unpredictable, nonlinear ways. We were watching an interstellar giant die in slow motion. And dying giants rarely fall gracefully. At 12:44 p.m., as if the universe decided to punish us for understanding too much, the main server chimed, 3 tones instead of 1. A priority alert. Ethan opened it. The room seemed to tilt. It was a combined dataset from the Deep Synoptic Array and the Gemini North Observatory. High-res imaging, spectral overlays, pattern recognition results. The message came with a priority disclaimer. Immediate manual review required. The images loaded, and we saw something none of us had imagined. A second fracture. Not on the main axis this time, on the lateral side. Shorter, sharper, new. "What the hell?" Ethan muttered. "That wasn't there 12 hours ago." Marissa leaned closer, voice hollow. "It's spreading. The structural failure is propagating across the nucleus." I expanded the time-stamped layers. The fracture had formed sometime between 0312 and 0427 UTC. Not visible before, clear as daylight now. And its orientation was wrong. It wasn't random. It aligned perpendicular to the primary fault line, as if the nucleus had entered a new phase of collapse. "What does this mean?" I asked. "It means," Ethan whispered, "our models are worthless now." He wasn't exaggerating. With two fault lines, each releasing microfragments, each altering rotational momentum, each driving internal pressure gradients, any simulation beyond a few hours was mathematically unstable. Even small changes in venting could introduce massive perturbations in trajectory. Even a millisecond of differential acceleration could shift the drift corridor. Earth wasn't in the impact path. Not yet. But a fragmenting interstellar object didn't need to aim. It only needed to break in the wrong direction. And with every new crack, the odds were rising. At 1:27 p.m., Washington called again. This time it wasn't Dr. Moss. It was an entire panel, voices overlapping slightly, the faint echo of a conference room, the tone clipped and urgent. "We need a consolidated update. What is the current probability of an Earth intercept envelope?" "We can't give accurate probabilities," Ethan said. "Atlas is entering nonlinear fragmentation. Our models can't keep up." "Estimate." "We don't estimate based on fractured data." "You will today." The room pulsed with tension. Nobody spoke. Marissa broke the silence. "Trajectory uncertainty is increasing exponentially. The drift corridor is widening, not narrowing. If the fault lines propagate, the object's mass distribution will change. We could see rotation shifts, unexpected jets, unpredictable venting. Any of these could push Atlas closer to Earth or away from it." "So the risk is rising." "Yes." "How quickly?" I stepped forward. "Hours, not days." The conference room fell silent. Then the lead voice asked the question I'd been dreading since dawn. "Is this object now classified as a potential impact concern?" We didn't answer right away, because answering meant crossing a threshold we weren't ready to cross. Finally, Ethan said, "Yes. Potential. Low probability. High uncertainty. But yes." The line went dead. Not ended. Cut. Someone on the other side had ended the call before hearing anything else. That was the moment I realized the government wasn't waiting anymore. They were preparing. Preparing for a scenario that wasn't just possible, but increasingly plausible. The shift from scientific anomaly to potential planetary threat wasn't loud. It wasn't declared. It simply settled over everything like a cold fog. Meetings behind closed doors, encrypted messages, lights flickering in parts of the building where no one should have been working that late. We weren't told anything, but we could feel the machinery turning. Slow. Heavy. Irreversible. And then at 3:12 p.m., the biggest shock dropped into our lab like a meteor. A new data set. International. From the International Southern Observatory. High-res spectrometry. The file was tagged with a warning. Preliminary, unverified result. Potential systemic anomaly. We opened it, and the three of us froze. Because the data didn't just show fractures. It showed movement. Not rotation, not drift. Movement. A subtle shift along the main axis of the nucleus, as if mass had migrated internally, squeezing the object like a slowly collapsing lung. "What is that?" I whispered. Ethan didn't blink. Not at the heat, not at the fractures, but at the rhythm. "The object is dying," he said. "It's adapting itself." And in that moment, more than fear, more than uncertainty, more than the widening threat corridor, I felt something I hadn't felt since this began. Dread. Because we weren't watching a collapse. We were watching a transition. Something inside 3I Atlas wasn't failing. It was changing. And whatever it was changing into, we had no model for it. No data. No precedent. No idea whether Earth was drifting into danger or whether danger was drifting toward Earth.
We didn't sleep that night. Not because anyone told us to stay awake, but because once you've seen the trajectory plots begin to slant, just a fraction, just enough to break the illusion of safety, you realize you're watching something that no one alive has ever witnessed before. The room felt tighter than usual. The hum of the servers was louder. Every light on the consoles seemed too bright. A few hours earlier, Atlas had been just a bizarre interstellar visitor, a dangerous curiosity, a scientific miracle wrapped in a streak of ice and dust. But now, as new data streamed in, from Webb, from TGO, from a handful of desperate ground stations, the object was becoming something else entirely. A question with teeth. The first message that broke the quiet came from the Jet Propulsion Lab telemetry hub. A single line of text, short, clinical, indifferent. Non-grav Excel trending upward beyond modeled range. No one reacted at first. It was too sterile to register as a warning. But then the next update came. Projected miss distance revised. And then the next. Shift persisting, updating confidence cones. The screens refreshed, and the room tensed as one organism. On the main display, the blue line, the nominal path, the one everyone had been repeating in press briefings like a prayer, was still safely far from Earth. But the red lines, the uncertainty boundaries, the ones that were supposed to shrink with every new observation, were widening. And one of the outer projections leaned inward like a slow-falling tree. I heard someone whisper, "No, no, no, no." Another person stood up too fast, bumping their chair into the table. A third just pressed their hands against the sides of their head as if holding something inside from spilling out. The shift was microscopic, less than 1/10 of a degree, but at distances of millions of kilometers, that was the difference between a safe cosmic flyby and an object that might just graze the edges of the gravitational corridor that leads home. "It's fine," Dr. Ellison said too quickly. "It's an anomaly, a photometric artifact. It's probably outgassing noise amplified through rotation. Give it an hour. It'll self-correct." But his voice lacked the conviction required to steady a room full of people who had been living inside uncertainty for months. And the plots didn't self-correct. They worsened, slowly, gradually, like something testing its boundaries, like something deciding. I was watching Atlas reposition itself in ways no comet should. Nothing explosive, nothing dramatic, just a steady, intentional-looking migration of the uncertainty corridor inward. "Recalculate with thermal lag," someone said. "Recalculate with mass loss asymmetry," another suggested. "Try the parabolic differential fit. Run the Mars-corrected range model. Filter out the CO2 jets. What about the albedo drift?" The room became a storm of competing instructions. Fingers hammered keyboards, data windows multiplied. The air felt hotter every minute as if the building itself was leaning forward in fear. Finally, Ellison slammed his hand on the table. "Enough! Quiet!" He looked at the cluster of updated plots, then at us. His shoulders fell. "It's not noise. It's real."
Silence spread through the lab like ink in water. And in that silence, every one of us felt the same cold truth creeping under our skin. Atlas was drifting. Not fast, not catastrophically, but unmistakably toward us. No one said the word, but it was there, unspoken, heavy. Collision. "We need probability numbers," I finally managed to say, though my mouth felt dry. "When does the corridor cross the Earth approach threshold?" "If the trend persists," someone answered, "in 20 hours. 20 hours. Less than a day until the models would show the first non-zero risk, the first sliver of possibility, the first hint that an object traveling for millions of years through interstellar darkness might end its journey here, on our doorstep."
All right, Ellison said, trying to sound steady. We don't panic. We analyze. We confirm. We present this to HQ and the department only when the trend is verified. But everyone in the room knew something he wasn't admitting. The trend was already verified. Across the lab, Maya Chen, our best astrodynamicist, a woman who had once corrected a broken NASA model with a pencil on the back of a grocery receipt, was staring at her screen with eyes that didn't blink. "Maya?" I said. She didn't respond. I walked to her station. "Maya." Slowly, she lifted a trembling hand and pointed at the rotational model. "Look." Atlas's rotation period had been stable for weeks, predictable, quiet, almost comforting in its consistency. But now the curve was changing. Faster in some phases, slower in others. A wobble, a torque, a hint that the outgassing wasn't random anymore. Something was shifting mass inside the nucleus. That realization hit everyone at once. Outgassing means jets. Jets mean thrust. Thrust means acceleration. Acceleration means change. But controlled changes? Directed ones? I felt a wave of nausea rise. Humans are good at lying to themselves, but not at lying to physics. "We need to consider the possibility," Maya whispered, "that the internal structure is reorganizing, that the vent geometry isn't stable, that the CO2 jets might be responding to something we haven't modeled, that the trajectory shift could be—" She didn't finish. She didn't need to. That it could be systemic, sustained, that it could continue, that Earth might not stay outside the corridor forever. At 1:14 a.m., the first official alert from NASA arrived. It didn't say much, but the weight was impossible to ignore. "Initiate Level 3 observation protocol. Continuous monitoring required. Prepare preliminary risk briefings." Level 3 wasn't evacuation. It wasn't even emergency, but it was the first level where the script changed from scientific curiosity to national concern. The room brightened with the cold glow of new screens loading classified overlays. Stomach-tightening words filled the displays. Risk projection, divergence trend, hypothetical gravity corridor intercept. Someone cursed under their breath. Another one whispered, "Jesus Christ, do they know something we don't?" I stared at the plots. The center line was still far, but its shadow, the potential future path, was expanding inward like smoke. "No," I said quietly, "they're reacting to what we're seeing. We're the ones ahead of them this time." The irony should have felt triumphant. It didn't. Around 2:40 a.m., the shift accelerated. Not wildly, not dramatically, but the rate changed. A clean break in the slope. The kind of change that says, this is no longer noise. "Run the Jupiter resonance check," I said. "Maybe it's external." But as the simulation loaded, the line on the screen told the truth before the numbers did. This wasn't Jupiter. This wasn't Mars. This wasn't the sun. This wasn't gravity. The shift pointed the wrong way. "It's internal," Maya said. Her voice had no air. "All of it." For hours, we watched. We plotted. We recalculated. We cursed. We denied. We accepted. The tension rose and fell in waves. Every few minutes, someone would gasp at a sudden data spike, only for the next packet to flatten it back to normal. Emotional whiplash, fear, relief,
Fear again. I realized at some point that we were experiencing the same pattern as Atlas itself, pulsing, expanding, contracting, building pressure. Around 4 a.m., a small miracle happened.
The drift slowed. The errors tightened. For the first time in hours, the cone stopped expanding inward. "There," someone whispered. "Maybe it's stabilizing. Maybe the jet shut down. Maybe the thermal gradient equalized. Maybe we got lucky." The hope in the room was fragile, desperate, childlike. Even I felt it. I wanted it. I needed it. Ellison straightened, pushing his glasses up, exhaling as if a weight had finally lifted. "Okay," he said, forcing the smallest smile. "Let's confirm. If it stabilizes by the next window, we can file a correction and—" The screen blinked. Once. Then again. A third time. Data froze, then jumped, then loaded. And then the room became so silent, the servers sounded like waterfalls. The new plot appeared. The new slope. The new shift. Sharp. Clean. Impossible. A sudden spike in non-gravitational acceleration. Not gradual, not progressive. Violent. A kick. And the vector? Directly toward the Earth approach threshold. Someone whispered, "Oh my God." Someone else said, That can't be." Ellison staggered back a step. Maya covered her mouth. I felt heat rush into my face, the kind of heat that comes from adrenaline and dread mixing until your hands shake. "That wasn't thermal," Maya said. "That wasn't rotational. That wasn't mass loss spreading. Then what was it?" A structural event. A crack. A collapse. A sudden shift in the internal distribution. A moment where an object older than human civilization suddenly decided to change its mind. I stared at the red line on the plot. Atlas had jumped closer to the corridor in a single instant than it had drifted in the previous week combined. "How close does that put the worst-case line?" Ellison asked, though he already knew none of us wanted to say it. Maya typed. The numbers refreshed. And there it was. A sliver. A thin thread of possibility. A fractional percentage that didn't exist yesterday. But today the universe had given us a new truth. There is now a non-zero probability that Atlas could intersect the Earth gravity corridor. A beat passed. 2. 3. "Meaning?" someone whispered. I answered quietly, because the words themselves seemed afraid to exist. "Meaning, if it continues to drift, it won't hit us." A breath of relief went through the room until I finished. But it could slingshot back toward the inner system, toward Earth, years from now. A new kind of fear entered the room. The long-term kind. The patient kind. The kind that doesn't vanish with sunrise. Ellison pressed his hands into his face. "We need to call Washington." Before he could move, the wall screen lit up. An incoming secure transmission from NASA HQ. No call was scheduled. No briefing was planned. No one expected this. The connection initialized. The screen brightened. The NASA administrator appeared. Pale, tired, eyes sharp with the kind of exhaustion that comes from too much knowledge and too little time. "We're seeing the same data you're seeing," she said without introduction. "We need your team to prepare a full risk escalation document by morning.
The White House has been alerted. No one spoke. No one breathed. And, she added, you should know something else. She paused. Hard. Heavy. The kind of pause that precedes a sentence that reshapes reality. The Department of Defense has activated Deep Sky Contingency Protocol. A hand slapped against a desk. Someone choked out a curse. Maya's eyes widened. Allison stammered, that protocol hasn't been used since never, she said. It's never been used, but it exists for situations like this. You think it's... Ellison trailed off. A threat? The administrator inhaled. Slow. Shaky. Human. She said, we think that the possibility can no longer be dismissed outright. The screen went black. No goodbye. No confirmation. Just black. For a long time, no one moved. Then finally, Maya whispered the words trembling in everyone's mind. What if this thing isn't done changing course? I stared at the shifting plots, the numbers still updating, the red line inching toward a future we were not prepared to calculate. Then, I said quietly, the morning Atlas crossed the gravitational sensitivity line, the world was still asleep. Pasadena looked peaceful from the second-floor windows. Streetlights fading, trucks rolling through intersections, the slow glow of sunrise stretching over rooftops. Nothing about the city hinted at the storm of data ripping its way through our monitors. Nothing suggested that an interstellar object older than the solar system itself had just made the smallest, most terrifying shift in its trajectory since entering our observational range.
In the lab, we were exhausted beyond language. Hours had passed since the last official call, yet no one had left. No one dared. The screens were alive with fresh telemetry, unfiltered, unpolished, brutally honest. Atlas had changed course again. Not drastically, not dramatically, but enough. Enough for the models to react like injured animals, throwing warnings, recalculating continuously, rewriting possible futures faster than we could process them. It's still accelerating, Maya said, rubbing her eyes. The outgassing pattern changed again. How? Ellison asked. Where? Everywhere, she whispered. She wasn't exaggerating. Heat wasn't concentrating along the fault lines anymore. It wasn't pulsing in its earlier rhythm. It had diffused, spreading across the nucleus like a fever migrating through a body trying to survive, or failing to. The new radial velocity plot appeared, jagged and unfamiliar. It's stabilizing and destabilizing at the same time, I said, hearing how insane it sounded. That's not possible. It is, Maya replied, if the internal cavities are collapsing in sequence, one after another. Cascade failure, Ellison muttered. Or reconfiguration, I countered. You're still on that? Have you got a better explanation for why the fault lines haven't blown the entire thing apart? Silence. Heavy. Thick. Uncomfortable. Because he didn't. None of us did. Atlas wasn't behaving like any interstellar object ever recorded. It wasn't following decay patterns. It wasn't following stability patterns either. It was doing something in between, something that looked like an instinctual reaction encoded in its fractured ancient core. And all we could do was watch. The room felt narrower as the sun rose. Long shadows stretched over keyboard trays. The hum of the servers deepened into a low, unsettling vibration, like the lab itself sensed the weight of the hours ahead. At 6:12 a.m., the system chimed.
A new update from the web team. We didn't breathe as the dataset loaded. New coma brightness. New thermal gradients. And then, a new shift. Small, but pointed. Oh God. Is it turning? Turning. The word was too dramatic, too anthropomorphic, too emotional for a scientific setting. But the truth didn't care about semantics. The shift wasn't random. The direction wasn't noise. The vector leaned, even if slightly, toward the inner corridor again. "Run it," Ellison ordered, voice cracking despite his effort to stay calm. Maya executed the model. The system churned, and when the updated trajectory rendered, the room fell so silent the air itself felt motionless. The new uncertainty cone brushed the Earth corridor boundary. Barely. Gently. Like a fingertip touching glass. Non-zero chance increased, Maya said, voice wavering. To what? Ellison asked. 0.1? 0.2? Higher. How much higher? 0.7. The number wasn't fatal. It wasn't doom. It wasn't the kind of number where you rush to tell the public or sound sirens. But it was the kind of number that meant something fundamental had shifted. The universe had rolled the dice. And Earth was now, however faintly, one of the places those dice might land. The administrator called again. Short, stern, fear wearing the mask of professionalism. "We need full documentation before noon," she said. "The president will request options. We need models, deflection thresholds, kinetic scenarios, hypotheticals." Deflection? Ellison repeated. At this distance? "We're not sending missiles," she snapped. "We're sending possibilities. They need to understand the stakes." "The stakes are uncertainty," I said. She paused. "Exactly." The line cut. It didn't feel reassuring. Nothing did. For the next 4 hours, we produced analysis after analysis, stress maps, predictive fractures, potential break-apart timelines, gravitational corridor overlays. But the worst moment came at 10:31 a.m., when a fresh dataset from Gemini North loaded. High-resolution imaging, crystal clear despite distance. The fault line, the main one, was closing. "That's impossible," Ellison whispered. "Objects don't heal." "It's not healing," Maya said. "It's collapsing inward." A collapse was the worst-case scenario. A collapse meant energy release. A collapse meant potential jet formation. A collapse meant thrust. And thrust meant acceleration. And acceleration meant... "If it collapses," Maya said, "the next shift could be the largest." "How large?" I asked. She swallowed hard. "Large enough that the trajectory might change by several thousand kilometers." "Toward Earth?" "Toward anywhere," she said, "but Earth is in the direction of the asymmetry." The room dimmed slightly as clouds passed over the sun. It felt symbolic, even though we tried not to think like that. At 11:18 a.m., the heat signature spiked. A microburst of energy. Short, sharp, unmistakable. Not an explosion, but close. "It's starting," Maya whispered. "The collapse is starting."
We waited for the next burst, the next change, the next tremble, but none came. Instead, the thermal pattern settled, quiet, controlled, waiting. Like the object was holding its breath. 1,000,000 kilometers away, a dying interstellar mass, older than humanity, older than Earth,
was pausing on the brink of a transformation none of our models could predict. And in the quiet, for the first time since this began, I felt something deeply unsettling. Not fear, not panic, something colder. Anticipation.
At 11:46 a.m., the collapse happened. We didn't see it. We felt it. The servers hiccuped as if struck. Every screen flickered. The plot windows jumped. Alarms triggered, quiet ones first, then the ones no one in the lab had ever heard before. Red banners slid across displays. Trajectory update required. Non-grav Excel spike detected. Radial velocity shift out of range. The data poured in like a flood. Heat bloom, fragment signature, pressure wave. And then the vector changed. In one violent, monstrous instant, Atlas shifted more than it had in the last 72 hours combined. Maya grabbed the edge of her desk. Ellison stepped back so fast his chair rolled into a cabinet. I didn't breathe. No one breathed. The new trajectory loaded. Slow, deliberate, cruel. A line sharpened across the solar system map. A line that leaned a little too far, came a little too close, entered a region no one wanted it to enter. There was no sound in the room when it finished calculating. No crying, no gasping, no whispering. Just shock. Pure, solid, unmoving shock. Finally, Ellison spoke. Very quietly. What is the new probability? No one wanted to run it, but Maya did. She had to. And when the numbers appeared, her face changed, not to terror, not to panic, but to disbelief. 2.3%. Silence. 2, she repeated numb. 0.3. Not high, not apocalyptic, but too high for comfort, too high for peace, too high for sleep, too high for denial. It wasn't a death sentence. It wasn't fate. It wasn't the end of days. But it was enough. Enough for the world to change. Enough for everything we understood about space, risk, fragility, and safety to crack. What do we tell them? Someone asked. Tell who? Ellison murmured. Everyone, I said. But before he could answer, the lab lights flickered. An emergency alert flashed overhead, then an automated message broadcast across the building. Level 4 contingency authorized. All personnel with risk analysis clearance report to secure briefing. Level 4. No one spoke. No one moved. Level 4 meant one thing. Not certain danger, not incoming impact, but potential. Real potential. A future where probabilities matter more than politics. A world where 2% is the scariest number ever calculated. In the quiet that followed, I stared at the last plot. Atlas drifting through our system, wounded, shifting, unpredictable. And us, tiny, fragile, impossibly vulnerable, standing in its path. I realized something then. Something no dataset could express, something no simulation could quantify. Atlas wasn't coming for us. It didn't know we existed. It wasn't an omen or a message or a weapon. It was just a dying wanderer from another star, changing, breaking, trying to survive forces older than light. And yet, even without intention, even without awareness, it could still end us. That was the truth we finally understood. The universe doesn't need to aim to destroy. It only needs to continue.
The alarms kept echoing overhead. People rushed into the hallways, papers scattered, doors slammed. But for one moment, just one, I stood still, staring at the trajectory on the screen. That thin red line, that fragile sliver of probability, that reminder of how small we are and how easily we can vanish without the universe even noticing. And as the world above us began preparing for scenarios no one wanted to imagine, one final thought struck me with absolute clarity. The real danger wasn't that Atlas might hit us. The real danger was that we had never accepted how easily it could. I turned off my monitor, and the screen went black. In the weeks that followed, life at JPL continued with the same routines as before. Security badges still beeped at the doors, coffee machines still jammed at the worst possible moments, and the hallway still echoed with hurried footsteps of people solving problems most of the world would never hear about. Yet something fundamental had changed. Not in the universe, in us. Atlas drifted past Earth at a distance safe enough to keep headlines quiet, but close enough that every scientist who'd monitored it felt the proximity like a phantom bruise. The final data package arrived 3 days after its nearest passage, a faint thermal echo, the last one strong enough for our instruments to catch. And then the object slipped into the outer dock, shrinking into a point of light, indifferent, broken, ancient, and free once again. People outside the agency celebrated the all-clear. Articles ran with triumphant tones about successful monitoring, minimal risk, a reminder of our vigilance. I saw colleagues smile politely for cameras, grateful that the public would never know how close uncertainty had pressed against the skin of the world. But inside the labs, no one was celebrating. Not really. Because we had watched an interstellar relic change, fracture, collapse, adapt, and continue, without rules, without patterns, without warning. And that truth stayed with us. The models were revised, the protocols rewritten, simulations expanded to include behaviors that had never existed in textbooks. 27 new research papers were drafted. Hundreds of late-night debates erupted in hallways and conference rooms. But beneath the intellectual excitement, beneath the scientific hunger to understand, there was something else. Something quiet and private. A sense of scale. A sense of fragility. A sense of being small in ways that our equations usually protect us from feeling. I remember the night I stayed alone in the lab, after everyone left, staring at the last captured frame of Atlas. It looked peaceful in that frozen image. Soft coma glow, fractured nucleus, faint tail dissolving into the dark. You would never guess that a few structural shutters separated us from a future very different than the one we inhabit now. I thought about how many thousands of years Atlas had traveled before crossing paths with our tiny world. How it had survived stars we never saw, collisions we never recorded, distances our minds cannot truly comprehend, and somehow, after all that, it came close enough to brush the edges of human probability. Not by intention, not by design, just by existing. That was the truth I carried home that night. The universe is full of objects just like Atlas, wandering without purpose, following trajectories as fragile as cracked glass. And we are here, small, temporary, breathtakingly lucky, trying to predict the whims of a cosmos that does not know we're watching. Before leaving the lab, I switched off the final monitor. For a moment, the reflection of the dark screen showed my own face, exhausted, humbled, older in ways data can't measure. Then the glass caught the faintest glimmer, a pixel of residual light, like a star refusing to die. I blinked. The pixel vanished. Just noise. Probably. On my way out, I realized something simple and unsettling. Atlas didn't bring fear into our world. It revealed the fear that was already there, the fear we bury beneath formulas and confidence, the fear that comes with understanding. And still, I felt grateful. Because for all the danger, all the sleepless nights, all the numbers that threatened the quiet balance of Earth, Atlas left us with a gift, a reminder, a question, a quiet message scribbled across the sky in dust and fractured stone. You are small, you are fragile, but you are here. And sometimes, in a universe like ours, being here is the rarest miracle of all.